Hello and welcome to Friendly Pharmacy 5. Today I have a very special guest with me. We have expert immunologist here, Dr. Kelly McNagny. Kelly, thank you so much for joining us. I'm really excited to chat with you.
Very happy to chat with you as well.
Dr. Kelly McNagny completed his Bachelor's of Science in Biology and Biotechnology at Worcester Polytechnic Institute in Massachusetts in 1984. In 1990, he completed his PhD in cellular immunology at the University of Alabama at Birmingham. He went on to complete his postdoctoral studies at the European Molecular Biology Laboratory in Heidelberg, Germany. Dr. McNagny runs his own lab at the Biomedical Research Center at UBC in Vancouver, British Columbia. He is a professor of medical genetics and biomedical engineering, where his work focuses on stem cell behavior, innate immune responses, inflammatory disease, kidney disease, cancer biology, and therapeutics. He has a leadership role in the Canadian Stem Cell Network Centre of Excellence. He is the former Associate Scientific Director of the Canadian Allergen Network Centre of Excellence.
Dr. McNagny, there's been a lot of information going around social media and different sources, and there's just some things that I think that people are still legitimately concerned about with the vaccines. And so I just wanted to go over some of those things and draw on your expertise a little bit as an immunologist as to what your thoughts are in regards to the vaccines and how they work, and even the virus itself, the SARS-CoV-2 virus. Maybe we could start there, Dr. McNagny. Could you tell us how a virus infects our cells, and how is that different maybe from how the vaccine actually works in our cells?
Sure thing. So every virus, in order to replicate, has to find a cell that it can infect, get inside that cell, and then make copies of itself. Cell turns into a virus factory, and then it releases all those viruses. And in the case of the SARS virus, somewhere on the order of between 500 and 1,000 viruses get emerged from a single cell infection. So that's like a big viral factory. And what your immune response tries to do is it tries to shut down the factories faster than they can spread. And when people get infected with this virus, people wonder why it's so variable. And I think a lot of that has to do with how much virus you're exposed to when you first get your infection, and then how quickly you can respond to it before it infects more cells and gets to spread around your body. So all viruses infect cells, they make copies of themselves, they infect more cells. Vaccines, in particular the RNA vaccines that we're using for the COVID virus, they're a tiny bit of a virus that can't make copies of itself. So it's really almost like a drug. That gets inside a cell. That one protein, instead of all the proteins from the virus, gets made in that cell, and then you make an immune response to it. So you trick yourself into thinking you've got a viral infection, but it's not replicating. It doesn't spread like a virus. And that's the big difference. And that's why you get infected rather than getting sick from a vaccine. This particular virus doesn't go in your DNA. It copies itself in the cytoplasm of the cell.
Oh, right, because it's RNA virus. Yes.
Correct. It's an RNA virus. But what you also have to think about is every time that virus replicates, because it's an RNA virus, it can make little mistakes. And that's where you get these viral variants emerging that people are concerned about. The more bodies a virus passes through, the more chances you have for making more of these variants that either don't respond, our vaccines don't respond to, or that can become more infectious or do more damage when they do infect you.
And I've heard that there are some concerns that because we are putting a piece of this mRNA into our body, it's going into our cell, and then it's causing the body's own mechanism, it's using the body's own mechanism to produce its own protein. I've heard that there is a concern about autoimmunity and the body actually attacking its own cell and thinking that it's producing the wrong proteins. As an immunologist, could you speak to that and explain that to us?
So anytime, as I mentioned, anytime a virus spreads in your body, it infects cells. Every time you get sick with a virus, it gets in cells and it expresses proteins on the surface of your cells, and you kill those virus-infected cells. Vaccines don't spread. The one cell that does get that little piece of protein, sure, you make an immune response to it, but it's not spreading throughout your body. So the idea that a vaccine is any different than a viral infection is ludicrous. It's really a much dampened down version of a virus infection. And I think that's something that the listener should always think about. You know, what we're comparing here is the risk of a vaccine to the risk of a virus. A vaccine is a piece of a virus that can't make copies of itself. You stick it in, you make an immune response, you're done. A virus is jumping throughout your body, doing God knows what, especially with this new bat virus that we know very little about. What we do know is that there are viruses that have been linked to autoimmunity. We know that there are viruses that have been linked to clotting disorders. This virus in particular seems to be really good at inducing a lot of clotting in your blood, and that causes many people to die. What else could I tell you? I mean, in every instance where people are concerned about a vaccine, I take a look and I say, wow, the literature they're citing about worrying with that vaccine, the risk is infinitesimal compared to the risk with the virus. It's, you know, it's 10 to 1,000-fold higher with the virus. Why would you be worried about a vaccine when you've got this virus to worry about?
Yeah, and I think this virus, I think it does it have 20 proteins or 20 something proteins that it's inserting into your body, whereas the mRNA is the spike protein.
It's the one spike protein, that's it. I've seen, you know, I can tell you all the myths I've seen on YouTube and other places. So there is this myth that the little bit of protein made by this vaccine starts spreading in your body and it causes clots. The amount of protein that vaccine can make is so infinitesimally small compared to the virus. There's just no way that's going to be a problem for you. You know, in very, very rare cases, people get clots from vaccines. With this coronavirus, you know, 1 to 2 people who get an infection die. 20% of the people wind up going to the hospital. 5% or so wind up in the ICU, and 1 to 2% die. If you look at the people who have been vaccinated, it's millions and millions of people across the planet, and the percentage of people who wind up in the hospital from a vaccine is infinitesimally small. So really, I think we're taking these things way out of proportion. The vaccines are safe. We've tested them, right? People are not getting sick from vaccines. The virus is not safe, and anybody who gets the virus is taking a massive risk. So you've got to compare relative risk.
Yeah, and with any intervention, there's never zero risk, but we all are in this situation where we especially with the Delta variant now, where we have this highly transmissible variant, and I think it's well accepted among the science community now that everyone will be exposed with the Delta variant now. And so it's a choice of whether you're going to risk this infection or get a vaccine that kind of gives your immune system kind of a little bit of, it's almost like a cheat sheet for the immune system. So it kind of has a bit of a way to recognize this virus. So it gives you a fighting chance before this can become like an inflammatory storm, right?
Completely correct. It gives you that leg up so that when the virus comes, there's already troops waiting to kick the virus. And you probably have heard in the news also a bit about waning immunity. So what
Yep.
protection is T cells, which fight the virus factories, B cells, which make the antibodies that mop up the virus that's floating around, and then the antibodies themselves that come from the B cells. When you get vaccinated, you make a lot of antibody, and those are just circulating around in your body, making sure that if they see a virus, it gets neutralized immediately and you're safe. Over time, those things tend to go down. The B cells that make that antibody, they're still there if you've been vaccinated twice, because they live a long time in your bone marrow and they sit there waiting to be called back into service. It's like the troops are in the barracks, but they're not there walking the perimeter, but they're there. They're waiting to go. You don't have to make a new army. The army's there and ready to go. You just have to call it. And that's the difference between a vaccinated person and an unvaccinated person. Unvaccinated person has no army. And it takes you a while to raise that army. And all the time you're trying to raise that army, the virus is spreading. That's the situation you don't want to be in. Now, with waning immunity, the troops on the border are kind of going back to the barracks. They will be called back into service. With every virus, it's a little different. Sometimes they're a little slower, and that's why you do get breakthrough infections. But it doesn't mean that you've lost all of your immunity. And overwhelmingly, the data suggests that if you've been vaccinated even months later, you still make a much better immune response than somebody who has no vaccination. And that's why you see very few breakthrough infections, whereas unvaccinated people, the virus just runs rampant and infects everybody and sends a lot of people to the hospital. So that's a big difference.
And I'm also hearing a lot about natural immunity. So people who are wondering about whether maybe they've had COVID before. Some people who actually know people who are waiting because they think they might have had COVID-19 maybe a year ago. And you're speaking about antibodies, you're speaking about B cells and T cells. I mean, how do we know right now how long immunity from an infection lasts? Is this something good to go by, or what is the science? What is the data that we have right now on this?
Sure. So the natural immunity people, and I hate that term because it doesn't mean much. What there is there's immunity or there's no immunity, and so
okay,
it's sort of the natural immunity bit. They kind of fall into two camps. There was this one paper that came out a while back where people were looking to see if just in the general population, people already had antibodies to this virus. It's a new virus. It just came out in 2019, December. But there were people who thought, well, maybe it's been around before and we're immune to it. And it's related to the common cold virus, which doesn't tend to kill a lot of people. So because of that, when you make an immune response to your cold virus, some of those antibodies will see this other virus and say, it looks a little bit like something I've seen before, and they may stick to it. But that's not testing whether those antibodies actually kill and neutralize the virus. That's
okay.
It's like, things are sticky. If I spill beer on the floor and I don't clean it up tomorrow morning when I walk in, my feet will stick to it. That's not specific. It's just kind of general stickiness, right? It's not going to protect you. And that's what I like in this kind of natural immunity. So that paper showed that if you look at the serum of people, you can find some antibodies that weakly stick to this virus. That paper in no way said that there's a pre-existing group of people who are immune to COVID-19. It's a myth. So you really have to be careful of that. I've seen papers saying 90% of the people have antibodies to this virus. That doesn't surprise me at all. Do they have antibodies that protect you? That's the key, and they don't. Really, most of the studies say that before 2019, none of us had an immunity to the virus. It infected everybody. So that's the one thing you can dispel. The second one, and this one is a little bit more tricky. If you have previously been infected with COVID, you have, of course, built up some immunity to that infection. That's how you cleared the virus. Problem is, we don't know how long that lasts. With the vaccine, we've tested, right? We've measured out the amount of vaccine you give a person. We've determined what the waiting period should be before you get your second dose. When you get that second dose, that's the one that really cements the memory in place and makes sure you're protected. And we know how long roughly that lasts too. So it's tested and it's tried. But with a viral infection, you may have got infected with a little virus and made a little bit of an immune response, not a great one. If you see a big dose of virus later, you could have no immunity to it and really get sick. So it's kind of like trying to play around with a drug that hasn't been titrated. It's like buying a drug on a street corner rather than going to pharmacy to get a drug. You don't know what you got when you got that infection and how long that immunity lasts. And that's why the vaccines tend to be easier to distribute widely and make sure you're protected. The other thing you should think about is for natural immunity. I've seen people say you should go out and get COVID-19 infection because then you're immune. 1% to 2% of the people die when you do it. Do you want to take a chance on 1% to 2% of you dying? Not me.
Yeah.
So that's not a great way to go.
Yeah.
And then the last one is, it's really to a certain extent hard to tell whether you've had COVID or not. I had a cold in the past 2 years. I was sure I had COVID. I'm pretty sure I didn't. But to actually show that there are tests that will tell you at the time you're feeling sick whether you've got COVID or not. But weeks and months later, it's not so easy to tell, and it would be super expensive. And you need an immunologist like me to try to figure it out. I think the natural immunity bit it's a thing, but it's not something I would rely on for protecting you from this virus. Even if you think you were infected, getting a vaccine boost is a great thing to make sure you're protected. It takes the guesswork out of it.
That's really interesting. So as an immunologist, you thought that you might have had COVID, and you, I assume, did not go and get yourself tested, nor did you hesitate to get the vaccine. Did you not even consider getting tested?
No.
No. And so, because I'm asking, because I know that you can get these tests in different parts of Canada, and you do have to pay a fee for this. And this is specifically, it's labeled as an antibody test.
Yes.
So these tests that are available to the public now, are these, you're saying that these are not the type of tests that would confer or give you the information that you need to know about long-lasting immunity. Is that right?
Absolutely correct. They will tell you, at the time, whether you have had an infection or not. They will not tell you whether that infection was strong enough to give you good immunity. And so I would argue against using those tests as any kind of a measure for whether you should or shouldn't get vaccinated. You should get vaccinated. And you can be sure.
Yeah. Okay. Well, that's really important to know, because I think a lot of people might be hesitating or wondering maybe they should get themselves tested. And it's not often we have access to an immunologist who can actually respond to this. And you didn't pursue this for yourself either. So
no. Getting tested is a great thing to find out whether you should stay at home and not go out and
of course
spread things, right? But it's not a great way to find out whether you should get vaccinated or not. That's a myth.
And just out of curiosity, if someone was to do one of these tests, I mean, I don't know the specifications on these tests, 8 months after their supposed infection, would it be at all helpful, or what would you expect to see in that test if that person did it?
I would expect it to be incredibly variable. It would be highly variable and hard to tell, I think. So if you had another infection, you would certainly go back and get tested again to see if you had a current infection. But I wouldn't rely on it to tell whether you've got immunity or not. There are some data out showing that people who have had COVID and then got a vaccination were really well protected. And in fact, to the point where in some cases it's higher, in some cases it's lower than people who just got 2 doses of vaccine. So great. Getting a vaccine was even better. It helped make sure you were protected. Those are from the studies in Israel where people were actually, some folks are trying to make the argument that was proof that natural immunity was better than vaccine immunity. And I think that was misinterpreted. What it says is there's some variability, and in some cases, if you've had an infection and a vaccine, it worked great for protecting you, but it's not something that you can rely on. Getting vaccinated is the only thing I think you can rely on. Okay.
And there's also some talk that after 6 months or 7 months, immunity is completely lost after vaccination. What have you seen in the data? Is there any truth to this?
So there's a modicum of truth to that. So what is true is that people tend to see antibodies dropping off after 6 months. That happens with a lot of viruses. As I said, it doesn't mean that your B cells and T cells have disappeared. It just means that those circulating things that are really going to stop the virus quickly are starting to wane. Now, where that becomes a problem is for people who are older, because it really takes them longer to ramp up their immune response, and you'd like to see more circulating antibodies in those people. That's why they're recommending a 3rd dose of vaccine for those folks. The other people that it's really important for are people who are on immunosuppressive drugs or have a compromised immune system. And those would be people who are undergoing chemotherapy, people who have had an organ transplant in the past. They tend to be on these drugs that kind of suppress your immune response. People who have autoimmune disease, if you've got lupus or MS or things like that, they tend to be on immunosuppression to prevent you from fighting your own tissues. So it's ironic that those are the very people that you'd like to see vaccinated more carefully, because despite what you may have heard about these vaccines causing autoimmunity, no, they protect those people who have autoimmune disease from getting a viral infection. It's the exact opposite of what you're hearing. So those are special cases where I think a third boost is really important now. The other thing that the listener should also understand is when we first rolled out these vaccines, we were trying to get as many people vaccinated as quickly as possible.
Right.
And so that's why 4 weeks after the first vaccination, people got their second dose. It was the shortest period of time they could give you a boost in to make sure you got a high dose. Now, since then, we've learned that actually delaying that boost makes the boost give you an even better protection. And so in British Columbia, by luck, we delayed the second dose.
Yeah.
And that actually probably went really well in our favor. So the immunity should last longer in us because we got an optimal time for the boost. Where you're seeing the breakthrough infections tends to be in places like Israel and the UK, where they were on that really short schedule where they got their booster shot really quickly and they didn't really delay it to the maximum point where it would have given the best benefit. It was because we wanted to get people vaccinated quickly. As luck turned out, we probably will do better here. Bottom line, though, is once we start seeing in the population people who have been vaccinated starting to show up in the hospital because they've gotten a bad COVID infection, not dying, because people who've been vaccinated tend not to. But once we start seeing a few breakthrough infections, that's when we should start considering maybe a third boost. And all the data suggests that a third boost really brings you up to much longer lasting immunity and will help. But for right now, I'm not seeing a sign that we should do that in a general public way, only for old people and people who have are immunocompromised.
And that's really good information. I was going to ask you about that as well, because we are seeing, especially in the United States, where boosters are becoming more something that's recommended for most people. And, they've really had a terrible, terrible time with the virus since day one. But here in Canada, and I think like you said, it was a bit of luck, and it was not without controversy, but it did seem to work out, and we are reaping the benefits of that. And so we are seeing that there is that longer term immunity, and it's not surprising that in older people, like you said, and people who are immune compromised, that they are needing a boost, because we know that these are the people that do not respond generally as well to any vaccine, let alone the mRNA vaccines, right?
Exactly right. In the older people, immunity wanes quicker and it takes them longer to ramp up. So that's why you want to really give those folks a boost when you see it waning. And so if the old folks start to show up in the hospital after they've been vaccinated because they are starting to see breakthrough infections, that's when you want to pull the trigger. And I think it's a good time to start doing that.
There was talk at one point about breaking tolerance and getting an autoimmune disease. Can you explain what this means? What does breaking tolerance mean in the world of immunology?
Yeah, so breaking tolerance is something you can do. We do it experimentally in the lab when we want to mimic an autoimmune disease. Usually the way you do that is really with some tough experimentation. You take a tiny, tiny bit of protein and take it out of its context, and you link it to something that causes a lot of inflammation, and you really stick it into a mouse over and over again. Then you can actually get an autoimmune response in an animal. You can cause it to start making antibodies against its own proteins. It's incredibly hard to do. And with vaccines, I haven't seen cases where it happens in a big way. With viruses, yes. There are cases of viruses that can induce autoimmune disease. And it's interesting with this SARS-CoV-2 virus, the COVID-19 virus, a lot of people tend to get these kind of autoimmune antibodies coming from the viral infection, not from the vaccine. So it's almost the opposite of what you've been hearing in the literature, that the COVID-19 virus has been linked to production of autoantibodies. And if you've heard a little bit about long hauler syndrome, where people tend to be sick for a long time after they've been infected with this virus. My suspicion, and it's just me, is that a lot of that is probably autoimmune.
Yeah.
And I think we'll see more of that later. But the long hauler syndrome is something that everybody should think about. Just because you see kids getting infected with the virus and not turning out to get really sick, doesn't mean we won't see some long hauler syndrome cases there. That terrifies me. Young people who get this virus and are fatigued and have difficulty concentrating and lots of these kind of neurological symptoms for months after they've been infected. That's in 10 to 30% of the people who get a COVID infection. That scares me. And people who get vaccinated don't get that. People who get vaccinated are protected from that. So it's another reason to get vaccinated. I always come back to, we've been making vaccines for centuries now, and they've given us a healthy life. We know what vaccines do. We don't know what a bat virus does. It's a new virus to us. It's a virus that came from a bat. It circulates in your body, just wreaking havoc on inflammation and everything else. It's not even close to what you get with a vaccine. I'm much more afraid of that, a new bat virus that's going through your body, than a piece of a vaccine that we tend to use for immunizing your dog so they can play with other dogs. I'm not seeing why we're so paranoid about vaccines all of a sudden.
Yeah, I had someone one time explain to me that, chronic fatigue syndrome or myalgic encephalomyelitis is like, you can actually see in the person's blood work that the immune system in some ways has almost rearranged itself. And this may be a bit of what we're seeing with long haul COVID. Have you seen or read anything along those lines?
I've always had that suspicion. I do have good friends who have, kind of that chronic fatigue syndrome. They think it's been linked to EBV virus and other viruses. Yes. But it's never been formally proven. But from what I'm seeing in the COVID-19 infections, it really looks like that. And I would hate to think that we're going to breed a generation of people with chronic fatigue, again, 10 to 30%, that's a high percentage, simply because they were afraid of getting vaccinated. That terrifies me. I think if you're vaccinated, you can rest assured that that's not going to happen to you. So why take a chance with a virus where you might get that syndrome?
I agree. I don't think that that's worth the risk. That's why I got vaccinated as well. And just in closing, Dr. McNagny, this has been really informative. Thank you so much. I just wanted to touch on this idea. I mean, we're in a world now of vaccine mandates that are coming out. I mean, our healthcare system has been overwhelmed. We have a highly transmissible variant, and mandates are now becoming more and more, I don't want to say popular, but they are becoming more and more common. And there is this thinking along the lines of, well, if I'm vaccinated, why should I worry about those who are unvaccinated? And, so as an immunologist, do you yourself worry about the vaccinated or the unvaccinated? I mean, how do you speak to this and put this into perspective?
Yeah, that's a great question, and I've even gone through that kind of mental thing myself where like, okay, my family's vaccinated, we're vaccinated. What's the harm in letting, somebody not get vaccinated and hang out with my family? We're protected, right? So I don't have to worry. Yeah. It's a very selfish argument, and I'll tell you why. So first, there are people who can't get vaccinated, right? We talked about some young kids right now currently can't get vaccinated. They will get infected with a virus, and we just don't know what it does to them long term. There are people who are immunocompromised, right? People who you probably dearly love. Some of your old folks who are getting, cancer and need to get immunosuppression when they get chemotherapy and things like that. You don't want to be spreading a virus to those people who can't make a good response, right? They're trying to get vaccinated, but they're still going to have a weak immune system, and you not getting vaccinated and infecting them could kill them. So that's again another reason why really not getting vaccinated is a very selfish thing. The third one, I can keep going, but the third one is the viruses, right? We're worried about making viruses variants that suddenly our vaccines don't work for. And then we'll be right back in this whole mess all over again, right? Where we're trying to make a vaccine quickly, we're trying to protect the population, but this virus has escaped. Every time a virus passes through a body, it replicates and replicates and replicates, and you make variants. So the only way to keep these variants from coming out is for people to get vaccinated. And the last one, even if everybody's vaccinated except a few people, and they go to the hospital because, again, 20% are going to go to the hospital when they get a COVID infection because it's that bad a virus. And my dad's got a stroke and he can't get to the ER because there's a bunch of COVID people blocking the ER and there's no care for him and he dies. My kid breaks his leg and he can't get quickly his leg set because there's all these people in the ER with COVID. My wife can't get her breast cancer surgery because they said, well, it's a tumor, it's growing, but we don't want to take you in because we can't do the surgery because all the surgeons are taking care of the people with COVID. That's something that really scares me. And you only have to look south of the border to see that that's truth. That happens in the States. It has happened in some places in Canada too. Mm-hmm. So, you may say that I'm taking my chances myself, and why should you worry? You're vaccinated. I worry because there are a lot of people who will be impacted by your decision. And, we could make a deal. You don't get vaccinated, you don't go to the hospital when you get sick. If you're willing to take that deal, maybe it's okay then. But if you're not willing to take that deal, step up, be a good citizen, agree that either you're going to get vaccinated, or if you choose not to, you're going to isolate, and you're not going to be socializing around people who may not be able to fight off this viral infection.
Yeah, and that's a really good point. And I don't think any of us have to look very far. I mean, if we are healthy ourselves, but to our friends or family, there are so many chronic illnesses. Over 40% of Canadians have one chronic illness. Some have more than one. So you really don't have to look very far to see those who are more vulnerable in our society. So I appreciate that point as well, that we do need to consider those around us. I mean, I don't like needles either. Personally, I don't want a vaccine, but I was thankful because I know that the data is there and that the vaccines are effective. But this is something new and we're all going through this as a society. So I really appreciate you taking the time tonight to share some of your expertise with us. There's still a lot of people who are still have questions, and it is totally legitimate to have questions and to look for a credible source of information. And that is exactly what you've given us this evening. So I really, really appreciate your time here. Yeah.
My pleasure. And I'm happy to talk to anybody. Honestly, I honestly don't think that most of the people who don't want to get vaccinated are bad people. And I respect the independence and I respect the concern.
Yes.
And I'm happy to tell anybody why I think that it's probably in your best interest to get vaccinated for you and for your family and your loved ones. And I don't think they're bad people, and I'm happy to chat with anybody.
And it means a lot coming from you. You're an immunologist. You don't work for a big drug company. You don't have an agenda. You're donating your time here tonight to speak with us and just give us an honest opinion. You yourself are vaccinated, and I know that your family is too. And that speaks volumes. So thank you, Dr. McNagny, for your expertise and all the information you shared with us today.
My pleasure.